Welcome back everyone, and welcome to two ways of solving the same algebra puzzle part 2. Remember, that was the original question. Find positive solutions for x, y, and z in this system of equations. I happen to call them equations 1, 2, and 3. So if I refer to them later on, we'll know what I'm referring to. And here is, we'll call it the Martin solution if you want. So there are the three equations. I just took equation 3 and I isolated that y. I divided each side by this bracket x minus y. So y equals z divided by x minus 1. And now what I did was see both equations 2 and this equation, I called it 3a when I manipulated equation 3. Both begin with y equals. That means I can equate them. If y equals this here and y equals that, I can equate z times x plus 1 and z over this bracket. So there I equated them. I set one equal to the other. And what I then do, I multiply each side by x minus 1. And that gives me z times x plus 1 times x minus 1 equals z. And next step, I can divide through by z. And of course, I could have done it that step first. I could have first divided by z, then done the other step. We get the same answer. So we divide through by z. We get x plus 1 times x minus 1 equals 1 because we divided out the z's. I multiply these two brackets. See each term by each term. I could say that there's a plus x, there's a minus x. And the middle terms cancel out. We're left with x squared minus 1. And those who know the pattern a plus b times a minus b equals a squared minus b squared could have got there immediately. So we've got x squared minus 1 equals 1. We add on 1 to each side. X squared equals 2. We root each side. X equals root of 2. Arguably, it can also be minus root 2. But at the beginning, they said find positive solutions. So we know that minus root 2 is not one of the answers, so it's plus root 2. So we've solved for x. So what I've done here, I've rewritten equation 1 and equation 2 from the original question over here. And what I've done, now that I know what x is root 2, I've rewritten both these equations directly underneath, except substituting in that root 2 for x. Instead of x equals root 2 equals, instead of x plus 1, I've got root 2 plus 1 on both these equations. The left side, what I did was I isolated that z. I divided each side by y, so we've got z equals root 2 divided by y. And now I substitute into this equation, which I wrote here. Instead of the z, I write root 2 over y. So y equals root 2 divided by y times root 2 plus 1 in a bracket. That's an equal sign, so what I do to the left, I do to the right, so it's still equal. I multiply each side by y, so we get y squared equals root 2 times root 2 plus 1. And I multiply in that root 2. Root 2 times root 2 is 2. Root 2 times 1 is root 2. Y squared is 2 plus root 2. Therefore, y equals 2 plus root 2 inside a big bracket. And this is exactly what I had with that part 1. I can simplify to these digits, and that either one of these is a solution for y. And now, if I go back to this equation, which I just rewrote over there, because we've just solved for y, I substitute the numbers in there to simplify for z, and we get z. I can leave it in this form. They didn't ask what form, or I can in decimal 0.76537. So there's the solution for z. There's the solution for y. I put squares around it so I'll easily find, and there's the solution for x. That's my method, which I prefer. And thank you all for watching.